Okay, hello. My name is Rafał Pocztarski, and this is, some of you may know me from Stack Overflow, actually, I don't change my old avatar because people recognize it more than my face sometimes on meetings like this. But that's enough about me. I would like to talk about some advanced TypeScript techniques to increase your builds and frustrate your users. And just a quick intro to the history of JavaScript, especially on the backend when with Node.js. We started with callbacks, and soon we got to some callback hell. You don't need to understand this code. This is just to quickly compare some few of the styles that we are using for programming. So we started with callbacks, and quickly it became pretty unreadable. So then we started using promises, which was pretty promising, and actually also led to some of the indentation hell that was known from callbacks. But when we started using async await, then it started being more elegant, but still not very readable for all of the things. Also, there's RxJS, which is also somewhat more expressive for certain tasks. There is FPTS that some people enjoy using, and it is also nice, but if it gets complicated, then it also is not very readable. Now there is FXTS, which, as you can see with those generators, with those implicit underscore functions that you yield with the yield star operator, it's much more readable than the previous examples. And also, as a bonus, using the underscore means that it's incompatible with both underscore and Lodash libraries. So this is like a bonus. But soon, when you combine all of those in larger code bases, you start getting functions that return types like this. And this is an actual example that I once saw. It's it's undefined there but it's not in the one line. So this is a function that returns a promise that is resolved to an observable from RxJS that just happens to contain some either of an optional type of some undefined and some error or some null somewhere else. And this is something that you sometimes get with automatically TypeScript says you have this type to handle, and then you have to you have all of the styles in the larger scope base mixed together, and it gets pretty complicated. And so I wanted to make some really simple test for myself. So I created a simple JSON, but in my test it was much larger, but this is the basic shape. So this is a list of users. Every user has an ID and a list of posts. And every post has also an ID, some content, and some number of likes. And I was testing some of the styles of programming with this data, but much larger. It was 1,000 users with each having 1,000 posts to make some comparisons. And this is two most obvious examples of how to handle if you would like to make all of the posts just uppercase. So this is a simple requirement. All of the posts that user wrote needs to be changed to uppercase. And the first one is something that I think most of the inexperienced users would be the first idea how to do it. You just loop through all of the users. For each user, you loop through all of the posts, and you just, the post content, set it to post content to uppercase. So this is really simple, 2 loops, nothing fancy. But it doesn't seem very, idiomatic, doesn't seem very sophisticated, very functional. It is mutating everything. So we might want to use some immutable data, some better types, some maps, and higher order functions or something like this. So more experienced people usually will get this data, return something that is mapped over using map. You change with the splat operator. This looks very nice. I sometimes write code like this. I see a lot of code like this, but there is one difference, and also it looks looks like TypeScript, looks like JavaScript. The first one looks like the same as like Java or C or something. And as the old story goes, a real programmer can write Fortran in any language. So this might be a good example of that. But I wanted to compare how this works in practice, because as you can see, all of the splat operators actually create new objects every time you use them. So the memory allocation has to happen, then the garbage collector has to free them. And for larger code, larger data, it gets to be first of all slower, and then you use much more memory. So comparing just those two examples, one is like just mutating it in place, and other is actually creating all of those new objects and all of the new arrays we're using map. And also what's important is that it's asynchronous. So the garbage collector doesn't even have any time to work until it's finished. So all of the allocations has to use the memory, and only later, when the garbage collector has some chance to work, then something of it might be freed. So I made some comparisons for 1,000 users, 1,000 posts, using something like this. I read all of this JSON to memory, so I didn't want to measure exactly like it has to be loaded anywhere. And then I tried to use the functions from the previous slides like 0 times to like have some basic idea of, without using those transformations, how much memory do I use, 10 times and 100 times. And what's interesting, this is the two functions are number 1 and number 2. And just for comparison, the number 0 wrote the same code in Go to see how like a lower level language would compare, but still garbage collector language. So I wouldn't like to compare it to Rust or Zig or C. And what's interesting is that the first naive, like beginner style of JavaScript is actually not using much more memory than a Go implementation. But that second style is using much more memory and much more time. So if you have like 100 of those operations, and this is like not very complicated, we often transform data in much more complicated way than just like setting one string to uppercase. As you can see, like having like 247 megabytes in Go and only just 325 megabytes for the first implementation in total for the 100 iterations. I was actually quite surprised, because this is like a current version of Node.js. I didn't use Dino, I didn't use Ban. So I was surprised how well actually Node manages memory here. But when you use the second implementation, for the 100 iterations, you get like almost gigabyte of RAM used. So you can imagine that, for example, you might have, I don't know, 500 megabytes limit of your, of your process in Kubernetes or something. And then it will just crash, because at some point, this was using the peak memory usage using the time command with -L option. And this is not, probably the process would not use this memory all the time, but when it peaks at some point and it is above the limit of, for example, your cloud provider or Kubernetes or something like this, or ulimit in Linux, then it will get terminated, and the services started restart, and you need to basically pay for larger server or something like this. So this have some consequences. So as I think that probably many people will think that the second version is more elegant, more idiomatic, more functional, more, a lot of advantages. There is some cost that we pay of using this, especially if you have a lot of those in a larger code base. And it's easy to like accumulate all of those little few megabytes more, and then you have like a simple service that takes hundreds of megabytes of RAM. And there is really not much to do about it, because the whole idea is that we are creating so much of new allocations of memory, and we usually don't think about memory allocation in language with automatic memory allocation. That's the whole point. We have garbage collector to take care of it. But if we completely not think about it, then the garbage collector can really have hard time working. And so this is like the real example of running very simple code and taking a lot of memory. And now the question is the map version with higher order functions with functional style, is it better than for loops? In what way better? Is it worth the cost? Because if it is better in some way, for example, one might argue that it's good to have immutable code, it's good to have maybe more readable code for some definitions of readable, and also maybe some tooling, some tools or libraries are easier to use using the functional style, but it is not free. It has some cost. In terms of, for example, memory usage in this example, and this cost can be non-trivial for some cases. And another, what is the cost? Because here the cost was the CPU, and as going back to the results, it was not only that the second functional style took almost a gigabyte of RAM instead of less than 1/3 of gigabyte, but also it took 23 seconds of time instead of 6 seconds. So it's not only you need more memory, so more expensive servers, but also you need more time, so probably you need even more of those servers to split the load so that your users don't complain that they have to wait longer. So there are some costs, and also the costs are CPU, memory, runtime speed, also compilation time, because this is not this is often overlooked. But when we work, sometimes we have compiling the code a lot of time during the day, and every time it's there's a huge difference. If I start a new build and it takes 20 seconds, and I'm not even losing focus. I'm just looking at while it compiles, and then I'm continue working. But if I know that it takes 5 minutes, then I will go grab some coffee, maybe start talking to someone, get distracted, and then I need to context switching. Maybe I'll try to do something else in this time. Then I forget about, I'm not in the zone anymore. So there is also the compilation time, I think, is important. Also, what are some other costs? There are some costs of readability, because if a lot of people are using different styles, then some new people are joining teams, and as we heard about it rightly so on the previous presentation, focusing on the team, you not only write for yourself, but you also write for your teammates to understand the code that you are writing. Maintainability, because if every time you are using different abstractions, like if you are mixing RxJS with FPTS, maybe there are some incompatibilities. Maybe you need to update more libraries. You need to focus on security, because using more dependencies means that you need to update the versions more frequently. Also, there is the comprehensive visibility, if there is such a word. So that how easy it is to comprehend really how the visibility is related to the way you can comprehend actually what is going on, because some of those examples, I think, and FPTS has this tendency, it is very theoretically it is very elegant, but every time I look at some more complicated code base using FPTS, it is not that I just can look at one place at a time. I need to understand the entire idea of what is it actually doing, and it is not such obvious as looking at as easy imperative style like the first example that we use with for loops. And also what I noticed preparing for this presentation, at the last time, just before I left to drive here, I thought that, oh, maybe let's add some effect.ts example to those tests. It would be interesting to have some more comparisons, but not having any time to do it really myself, I asked ChatGPT to maybe translate the other examples to using effect.ts. And every time I try to do it, and try to do it multiple times with ChatGPT from OpenAI, by Grok from X, and by Copilot, every code that they generated didn't even compile. So I mean, the AI is unable to write working effect.ts code for some reason. And this is, so I like invented the term artificial intelligibility as some way of thinking how your choices of technology adds another cost that is not to be overlooked today. That can you use the modern tools like AI to help you develop the code? If you are choosing the tools that the AI don't understand, they cannot write the code, they cannot refactor it, then you are losing one of the tools that you can use otherwise. So as AI is really amazing with JavaScript and TypeScript, I mean, I think those are most of the languages that are used in all of the documentations on Stack Overflow. So there's a lot of material to train the AI on them. For some reason, using FPTS also and effect, as I said, is very hard for them to write code that I didn't even wanted it to work well, but it just at least to be able to be compiled. And there was like syntax error, some imports that didn't work, and I tried it multiple times and failed to do it. So that's when there is no example on effect. But this is something to be think about, because once when you are choosing the technology or even style of using the technology, because like using the second example wasn't using any new libraries, there was no like RxJS mixed with effect and FPTS or something like this. It was just idiomatic plain JavaScript or TypeScript, but still might be arguably more or less readable. So this is something that we need to think about, especially working with larger teams. Also, maintenance would be maybe easier, maybe harder, depending on which style you are using. It's easier or harder to understand by people, but also I don't see it like talked about very much, but I think it is important and will get even more important. It can be easier or harder to understand by artificial intelligence. So, so this is something that when choosing this wrong style, or like, I mean, wrong, it's everything is like has some pros and cons, but wrong from the point of view of artificial intelligence. If the AI cannot help you work, then you lose one of the tools that you might use otherwise. And also, I would be interested if maybe there will be later some time for questions and some conversations. What good but costly techniques do you use that, for example, you know that it uses more RAM or more CPU cycles, it's slower, but it's for some reason better in your opinion? For example, I don't know, something, maybe it's safer, maybe it's type safe, but or maybe it's immutable or something like this. So I would be interested to know if you are like consciously using some techniques or libraries that you know that have some runtime costs, maybe compilation time costs, maybe memory overhead, but you still use it for some reason. And what is this advantage that you are factoring in? What is the cost that you are willing to take on yourself? And is it worth it? And some of the, that's basically this. So this is my presentation. And if you have some questions, you can find me on some social media if you want and talk to me later. But I would really like to hear some of you having experience with like knowingly using techniques that either makes it harder to like for the machine or for people or for teams or for some other way, or maybe like it's just more expensive because you can always buy a larger server, but it is a cost for the company that you're working for. So maybe if there are some questions, then I'll be glad to talk to you.
First round of applause, but I think we have a question in the back. Yeah.
Hi, great presentation. I have a hypothetical scenario. Let's disregard the costs, maintainability, readability, and the question is, can we do better than for loops and Go? Can
we do better than for loops and Go?
Yeah.
I think that probably Go is, I used Go here mostly because I think it would not be fair to compare to, for example, Rust or Zig or C or other low-level languages with manual memory management. So here we compiled something that has a runtime and has a garbage collector. But I think that Node is not very far from it. I was actually surprised. My idea when I started the test was that I thought that Node would use at least twice as much RAM as Go for these examples, but I was pleasantly surprised that Node is very efficient here. But it all depends. Here in this example, if I was to write something most efficient for exactly this, I would probably write something that streams the JSON from disk and like substitutes it's like on the go. You don't need to load everything in memory just to change the strings. You might write actually a set filter for it and in your shell for this example. But in general, it's very hard to say if you can use something like other than Go or loops in Node. But actually, when you are using Node, then using for loops, for example, when the Lodash project was started, basically because underscore was pretty slow and was not very responsive for like pull requests that make some performance improvements. And when you look at the Lodash source code, it's all loops and no fancy like mapping and methods or something like this. So because like having even nested loops, you don't have any function calls in there. You don't have memory allocations like you would having like creating new arrays, or you don't have the overhead of closures of like creating the scopes for new functions and things like this. So I don't know if you have maybe something more specific to ask about, like for what task you are asking, what would be the better? Because I guess it would be more like suited for your question. For this particular task, it could be even written in assembly, like streaming the file from disk to some other file or something, and you just checked if you are like nested enough. Once I wrote in assembly a filter like this to minify JSON, like remove the meaningless white space from JSON files, and it was quite an interesting. Like it was not like for anything useful, but just a learning experience. And I advise everyone to do something like this, to write anything in assembly, to try to read a file, to stream a file, and you could use I guess few bytes of memory just to process these tasks. But usually this is an example that usually you don't have like this single task and nothing else to do, but usually you have some data in your memory. For example, maybe you need to anonymize some of the data before you send it to some logging service, like, I don't know, maybe surnames of people, you need to like change it to stars or something, but you usually keep this thing in memory. But for things like this, I think if you already have this in memory, then I think the loops would be like using the least memory and would be the fastest. But arguably, maybe it is not elegant for someone. But we need to understand that there is a cost of this elegance. I personally enjoy like sophisticated abstractions in programming. This is like something that I like myself, like it's fun, but then some of those are we rarely think about using. I think that using the very high-level programming language, we forget about those memory allocations, forget about the bytes that are there. We forget about like how much kilobytes or megabytes your structure takes in memory. So for this, actually, I wouldn't even use Go for this probably, or not as just loading everything in memory, but try to do some streaming. But this is like contrived example that wanted to show just that everything is, there's no simple answer to anything, I guess, if that is the good answer to your question.
Thank you very much. It sounds like there's more to this.
Before the talk, you told me that I shouldn't restrain myself from time because we have a lot of time.
But remember, I also said the closer I get to you, the more you have to make shorter sentences.
Okay. So you can just hit me or something.
This is something that I think there's going to be more follow-up on this, but we are a little bit now raced for time. So we want to have one more speaker before we do. But thank you. One more round of applause for Rafał. Thank you so much. Thank you.
Thank you.